sent by Dr. Chairat Bunchaliew. He is head of the HPB unit at the National Cancer Institute in Thailand. And he is one of the members of the Thai Hepatopancreatobiliary Association. And he's one of the organizing committee of the AHPBA 2025. Please welcome Dr. Chairat.
Good morning, Chairman and the audience and all the online. I would like to thank you, the committee, that give me the opportunity to talk about this innovative session. My topic today is about the C3 volumetry and the 3D imaging for transforming. First, I have no financial disclosure and conflict interest with the material in this presentation. So about my talk, I have to find content. You can see that the introduction, the volume, analytic, navigation, and the future. So the first one, I talk about the introduction. The 3D imaging is help a lot about for the decision, for the planning before your operation. Previously, if you know that you make a 3D, if you don't have the program, it's not possible. Some of my mentors told me that they can look at the film and they can create this inside their imagination while they operate. I think that is not possible and not easy to learn that way in the young surgeon. So for me, I think that learning from the 2D and 3D, it should be a better nowadays. If you have skill like my mentor, it should be good. But if you don't, maybe the 3D can help you a lot. So let's start with the first one. It's about the volumetry. Why the volume is matter? I think we all know about this one. This is Maguchi criteria, that is decision for to make the operation for the patient in the liver resection. I think we all know that it's about the limitation of this criteria, because they don't mention about the volume. You can see this if we have two patients. This is two patients together. They are the same. Everything is sex, the liver function, the Chi score, and they have to do the right hepatectomy in the both case. If we follow the Maguchi criteria, which one do you think that the patient may have a problem after operation? I think we all know that the small case, the small liver tumor is may have a chance to have a problem, which means that sometimes the volume is matter. Not mean just the ICG is good, the liver function is good, so you can operate. It's not true. So it's about the 3D. What is you learn about this? Previously, before we have a 3D program, we have to make it some kind of drawing by our hand, by the manual, by ourselves, to create a 3D image, to look at and calculate the volume. But nowadays we have a lot of programs that can calculate. Sometimes that is very easily to use. So I will show you the previously what we did, something like we call the manual. If you see the patient like this with a mass in this area, you have to calculate in a 3 step. Make a volume of the tumor first, and then the volume of the total liver volume, and the last one is about the remnant volume. So this is the step that you can see. So the first one you calculate for the volume of the tumor first. You have to draw it at the tumor area, and then you calculate by the program. And the next one you calculate the total of liver volume by drawing cut by cut, slide by slide. It takes more times. And then the third step, you should have to calculate the remnant by drawing. In this case, you plan to make a right hepatectomy. The remnant should be the left lobe. So then we go for the formulation. This is standard formulation, should we all know. The first step we should calculate is about calculate the total function liver volume by using the total liver volume subtract by the tumor volume. So in this case, you can see the total function is about 1033. When you formulate, this patient have the FLR is 77%. So which means that it's very small. So you calculate like this. You take time. How long that you take? If you draw by your hand, it depends on your slide. If your slide of the CT is very big, you should less time to use to calculate. But nowadays, even in my institute, we can have a 0.5 millimeter of the slide of the CT, which generate around 300 to 500 image of the whole liver. Which is if you draw by your hand or 500 and make it 3 times, maybe you should take time around half day. But is it good or not? I think it's no. Another problem is about by the manual is something like this. If you see the patient, we have a lot of artifact inside, a PVE, or sometimes you face with a PVE with a lot of cysts or tumor inside. The calculation by your hand is possible, but it takes more time and very, very difficult. So I show you that is nowadays that is very easy one. This is a real video that I used to calculate in this patient. So you can see this. I'm not cut or skip anything. First, we calculate the volume first and then make the program to generate the IVC and then generate the portal vein and hepatic vein. This is real time, so you can see that it's just a little bit, but it's really easily than you draw by your hand. Then you get a vein and then you make a tumor. Okay, then you make an observation. So now you see this is a tumor and a liver. It's just in 1 minute. It's easier than you draw by your hand. So now you can see that you can have a total functional liver volume and a tumor volume by just 1 minute. If you make your hand, maybe 30 minutes or something. The next one is about the analytic and the simulation. What is the program can do for you? First one is about to analytic of anomaly. It's very important because before you go on operation, if you know anomaly, sometimes it's helping you. Sometimes it's make your life difficult for operation. If you don't know about this before you go in, they should have a problem if you go face some critical criteria in the operation. Apart from the anomaly, you can learning and studying the segmentation. Something like this, you can see that is we call the dorsal ventral segmentation, even for the cranial and caudal segmentation. And look carefully, you can separate more in the subsegment in this area. Not only just anomaly or the segmentation, it can help you for the decision. Look at this, it's a case. If you see the case like this, tumor at the segment 8 is like this. If it's just a benign tumor, maybe cyst or like a hemangioma, something that you need to operate, maybe segment 8 resection, it should be fine. Maybe just a remnant is around 84%. But if it's not, if it's a cancer, what is your plan for your operation? If segment 8 is possible, you can do it. But if it don't, you can make it calculation for you, just like a right anterior or the right hepatectomy if you need. The thing that is very good that is some kind like prevent you from the injury or the problem. If you plan to make anterior sectionectomy, and the right hepatectomy is another option, but the right hepatectomy is not possible because of the volume is not enough, which means that it can prevent you from do harm while operation. Because of you all know that if you did only right anterior, patient is safe. But if you make an injury, sometimes you injury the bile duct of the right duct or right portal vein, you have to ligate the right portal vein, which means you have to make a right hepatectomy. Maybe your patient is maybe die. If you know about this, before you can go in, so you can make a preparation and if you think that some area is dangerous, you can skip that, you can avoid that. Maybe it's bad for the operation. Another one that I like is about the planning. You can see the patient here is a tumor on the segment 7. Maybe you plan for the segment 7 resection. And we all know that the operation on the segment of the higher lobe had a problem about putting of the planning for the port. And this you can see that you can make a program to do a planning for you. This is some kind that is, you can see the green area is a fatty area. If you can make a deform, you can see, I will show you back again. They can make a deform abdomen like you make a pneumoperitoneum. You can adjust by yourself the which size, which volume that you want. And after that, you can make a toe position. It's something like the first one, we all made that mostly on the umbilicus. We point at the liver, and then you can see what is problem. If you see when you make a port here, you can rotate, you can check, and you can go in the port to look inside what this area is good or not. See, it's a liver here, so you can make a seeing inside before you can go in. But we all know that it's a tumor on the segment 7. If you want some kind like advancing the trocar at the first one, so you can make an upper, you may kind like a skip at up. In this case, we put it more upward in the upper abdomen, around 5 centimeters, and we make another trocar here, and we can look in here, but it's what we look like. You can see liver? It's okay. About the tumor, where is tumor? If you subtract all the organ, you can see the area that is maybe suitable for place the trocar. You can take the liver out, and you can take the inside structure out. Here is tumor location. So I think if this part is a good area that you can place the trocar in this place. It's because it's a point directly to the tumor. It's very easily to make the operation. This thing is good for the program. If you have it, it should be good for you. Another one is something that you can make it on your desk. Prepare everything, think every option before you can use it in the operation. You can connect with the line or the LAN. You can use it in the operation room. Or the another option, you can make it on your hand, by the phone, by the tablet, something like this you can download. You can look at your hand before you can go in operation. Review the anatomy, the area, look inside, you can remove, you can subtract, and you can carefully check that is this area is safe, this area should be cut or should be spared. So for the last one is about the navigation. We had a problem because of when we go in the liver, sometimes we lost the way. Previously, there has a lot of trying that we try to overcome this problem. The first one is about the model. We all know that we don't use this anymore because it's expensive, it's very heavy, and the problem is it's some kind like a solid. When you cutting on the model, there is a inside parenchyma structure is not moving with you, which means that we face with a problem that we call the deformation. Deformation is mean that inside the structure not moving as a real life. When you make the operate on the liver, when you track the liver, you see that inside is moving. But when you make the model like this, it's solid. It can. The closest program that they can try to overcome the deformation is thing like that is called, the example is a CAS1. They put a 3D inside the machine and they make a pointer of your instrument to make a point at this area on the liver to registration and make this like it. When you are pointing here, the imaging is moving with you. This also is good only abrasion, but for the resection is the same problem. About the deformation is cannot overcome. Another one that we have seen that in many papers, they try to make a hybrid or the augmented reality to embed, to infill, to combine the picture together to make it like easy to find the location of the tumor. Yes, only just a tumor. But for the inside, the vein the structure is not moving when you make operation. What do we do? Mostly nowadays that we can do now is just make a like a finding inside a parenchyma structure that we make it like a landmark. So in this case, you can see that we plan to make an operation on the segment 8. Think that you have to consider where is the segment 8 location. So we make carefully to evaluation. This patient have the 8V and 8D and the vein. And when we combine and we make a plan that we plan to cut and we plan to save, you can see that it's a very small V5 here that's close to the segment 8 pedicle. If you're looking at here, so you can find that segment 8 very easily. Let me show you some video that is about this case. So I will show you very quick after you take the gallbladder out. So you try to make the highlight approach first. After that, you found this structure should be above the right anterior. After you make the end circle, you clip with the hammerlock. Oh, sorry, it's a bulldog. Yes, you can see it's just a 8 ventral, not cover the 8 dorsal, just a part of it. So you go as your plan by open the Cali line and find the middle hepatic vein. After you found the hepatic vein, you follow it and you make a area that you plan is a V5. This is a V5 here that we seen in the program before we go in. It's very small. You have to cut it first. Then you make an end circle, you cut it. And you can see that the close of it, when you dissect, it's just about half centimeter. You see the clip, the hammerlock, it's a bulldog that you clip it, which means that exactly the same location that you found before you can go in. I think this call we can use it like a landmark before we make the operation. It's guide you like a navigation. It's a close setting that you can because of they can overcome the problem of the deformation. So okay, I skip it once. For the future of the 3D imaging, because the big problem now is about the deformation. So now you can see that there is some program that can try to overcome this one. In this case, you make operate on the left side. You can see the inside structure here. On the right side here, if you can make like an example like this, you can track it, make a deform. You can see the inside structure. You can see that it's moving with you. The problem is about they cannot overcome the steep of the liver, but in the future I think they can. It should be good for you try to embed this or infill this piece with your imaging in the laparoscopic. You can make this very easy and you overcome the navigation problem and you don't lose your way. So the conclusion, currently they have a lot of 3D programs that have variety for the application. Choosing the appropriate program for the situation will ensure the smooth surgical planning, and if it's necessary to modify the surgical plan, the program can help to design the best and the most precise treatment for the individual patient. So this year we have a APSVA in Bangkok in October. If you're interested, I would like to invite all of you. Thank you.